Alright, so we talked about the concept that whenever you have a velocity versus time graph, if you plot your function, you can find the average acceleration between 2 points by finding the slope of the graph, or the slope of the line. Because the slope is rise over run, so we're going to do change of velocity over change in time. But once again, what happens if instead of wanting to find the average acceleration between 2 points, you want to find the acceleration at some time t at a single moment in time? That means we want to be able to decrease our delta t to be as small as possible, so right up against the point of interest, which is the same thing once again as taking a limit, very similar to what we did with position in time and finding velocity. So we're going to find that the acceleration is going to equal the limit as delta t goes to 0 of dv dt, which is the same thing as taking the derivative in terms of time. So we're going to take our first derivative. Now once again, I'll remind you that acceleration is a vector, which means that you may have to do an x component and a y component separately. So in order to find the x component, you would take the first derivative of the velocity function in the x direction in terms of t. And to find the y component, you would take the first derivative of the velocity in the y direction function in terms of t. So you've got to keep track of x versus y terms. And since the derivative of the position function is the velocity and the derivative of the velocity function is the acceleration, we could also take the second derivative of the position function in order to get the acceleration. So we could take the second derivative of x in terms of t and the second derivative in terms of y in terms of t. So remember, that gives you an x and y component, and you have to use Pythagorean theorem and inverse tangent to find magnitude and direction.